Okay, here is a Unit 3, we'll call it a practice test. Basically some problems that I went through and picked out that may or may not be similar to some problems that you see on the test. So you can use this for whatever it's worth. Okay, so first, number one there, we're going to solve for x in each of those equations. You see that the x is at varying places, okay? Sometimes in the exponent, letter B, it's not in the exponent. Letter C, it's back in the exponent. So we may or may not have to use logarithms to do this. See, the trouble is a lot of people learn about logarithms. They think, oh, every time I have anything with an exponent, I use a logarithm. But that's only true when the variable is the exponents, okay? So I would say letter A, we can change this to common bases. 81 and 9 are odd numbers, so they have a base of 3. So 1 over 81 is going to be 3 to the negative 4th, and then that's an x minus 2. Sorry about the print. Okay, and then 9 equals 3 squared. All right, and again, once you have common bases, you can let the exponents equal each other. So we end up with negative 4, x minus 2 equals 2. And I would assume that all of you could solve that from that point. Okay, but that would be the key idea there. Now, letter B is a little different. X is no longer the exponent. Well, if this was x squared, you would take the square root of both sides. If it was x cubed, you'd take the cube root. Well, in this case, it's x to the negative 4th. So you're going to take the negative 4th root of both sides. So x is going to equal the negative 4th root of 64. Now, you can use your calculator to do that. Okay, or you could use mental math to do that. Either way, it does not really matter to me. If you're going to use the calculator and use the x root function, you need to put the negative 4 in parentheses to be able to do that. Okay, so the negative 4th root of 64 ends up being 0.3535. Okay, and then last is letter C. And here we have an x as an exponent. Now we're going to use a logarithm. Again, anytime you have that, you want to take the log of both sides. So log of 3 to the x equals log of 25. Power law says I can bring my variable out in front. So x times the log of 3 equals the log of 25, which means x equals log 25 divided by log 3. Okay? And you would want to use your calculator to determine that. Okay, so x ends up being 2.93. All right. Translate the following from log form to exponential form or vice versa. And that's just something you need to be able to do. Okay, I gave you a key for this, sort of like your little matching game there, where I said, you know, square to the circle equals triangle, or something to that nature. And then the conversion would be circle equals log base square of triangle. Okay, so that could be something that you put on your study sheet. Anyway, here we go. 2 to the x equals 16. All right. Log base 9 of 81 equals x minus 1. And x to the 3rd equals 5. Doesn't ask you to solve. It just says translate. So convert each of those. Okay. I'm going to move on to a couple other problems here. So if I scroll down, take a look at number 3 and 4. So 3 is still a Unit 3 topic. Okay, it's known that 12% of certain drugs are removed from the body each hour. This is similar to what we had on the team test. Team test is a little tougher. All right, if 30 milligrams is given at time 0, write an exponential function that gives the amount remaining after t hours. So this it's just in hours. Okay, there's no minutes. It's not every third hour, things like that. So no tricks here. All right, again, we're looking at y equals a times b to the x. In this case, our initial value is 30 milligrams. Okay, so 30. Our multiplier is 12% removed, so that's 1 minus 0.12. Okay, that's 0.88. All right, to the t power. So d of t equals 30 times 0.88 to the t power. Use logs to express exactly when 10 milligrams remain. That doesn't mean actually compute it. That means a logarithmic statement should be given. So 10 equals 30 times 0.88 to the t power. So I divide both sides by 30. A lot of people want to subtract for some reason. 1/3 equals 0.88 to the t power. Okay, anytime you have a variable exponent, again, cannot stress to you enough, taking the log of both sides is the only step available that we know about. Okay, so, and then my power law brings that variable out in front. So log of 1/3 equals t times the log of 0.88. And I divide both sides by 0.88. So use logs to express exactly. It would be log of 1/3 divided by log of 0.88. Doesn't get any easier. Okay? Now compute this time t. So t is going to equal whatever you get when you actually punch this into the calculator. Next here, this is a little review. This should be Algebra 2 review here, people. There should be no difficulties, all right? Now, I'm going to do the tougher ones. -4, plug -4 in, okay? When g of x equals 72, plug 72 in. So I'll do the first step for you because some people goof that up. 72 equals 2x plus 7 squared. First step's divide by 2. So 36 equals x plus 7 squared. Now, this is the step where a lot of people goof up. All right, they forget that when you take the square root of 36, how many possible answers do you have? 2. So the square root of 36 is 6 and -6. Okay? And then you can go ahead and solve that. Letter B here, find a minus 5. So 2, and then a minus 5 plus 7 squared. And simplify that. So a minus 5 plus 7 is a plus 2. Square that using your generic rectangle. Do not distribute the square. And then distribute the 2. Order of operations. Find the inverse of x. So here we go. X equals 2y plus 7 squared. Okay, so we're going to divide by 2 first. So x over 2 equals x plus y plus 7 squared. Then we're going to square root both sides. So square root of x over 2 equals y plus 7. And then we're going to subtract 7. So the inverse ends up being the square root of x over 2 minus 7. Okay. Let's scroll down and do a couple more. All right, factoring. I know a lot of you struggle with this. Whoops. All right, I won't scroll way down there. Sorry. Factor each expression as necessary. Okay. And the one that most people struggle with is this one right here, because we end up with the difference of 2 squares. So first of all, they both have a p and an r in common. And when I factor each of those out, I end up with r squared minus p squared. Okay? This is the difference of 2 squares, which can always be factored into 2 binomials. Okay? And if you don't want to factor it the long way, then here you go. Here's the shortcut. How many r's do you have? You have 2. So put 1 in each. How many p's do you have? You have 2. So put 1 in each. What's the only way to multiply and get a minus? Plus, minus. Okay? And that's your final answer. This PR out here that you did first doesn't go anywhere. All right, here you got to factor a 3x out first. Here you got to factor an x out first. And then it should be just your factoring trinomials that you have from before. Okay. Let's scroll down here, maybe look at another problem. And if you ever need answers to any of these, you just let me know and I can go over them in class with you. An exponential function passed through the points 2, 18, and 4, 162. Is it increasing or decreasing? Well, let's see. At 2, it was 18. At 4, it was 162. It is increasing by a lot. Write an exponential equation using the points above in the form y equals a times b to the x. Stat, edit, put your x values in L1, your y values in L2, stat, calculate, exponential regression. Okay? If you don't know how to do it by hand, there you go. That's your answer, okay? You got to know how to do that. All right? But if we're doing it by hand, we end up with 162 over 18 equals b squared. Okay? Again, I just divide these two and then subtract these two, and we take the square root of that. So let's see here. Lost my calculator. So 162 over 18 is 9. So I end up with 9 equaling b squared. which means b equals 3. And then I substitute b back in, okay, to my one of my equations, which would have been 18 equals a times 3 squared. So 3 squared is 9, 18 divided by 9 is 2, so a equals 2. So remember that it said to write an exponential equation, so the final answer has to be an equation. So y equals 2 times 3 to the x, which is the same result that you would get if you used a calculator. All right. Number 7, you have $500 to invest in the new Kearney Savings Bank. Bank pays 5% interest annually. Write a formula to calculate the amount of money you will have in the bank as a function of time in years, provided the interest is compounded weekly. There are 52 weeks in a year. Okay, so again, you can use any formula you want, but I would encourage you to use something like this. Principal 1 plus r over n to the nt. Okay, fill in what you know. P is principal, which is the original amount. Okay, n is how it's compounded weekly. R is interest, 5% or 0.05. And t is time. That's our variable right now. Okay, so my equation would end up being, let's just say f of t equals 500 times 1 point, and I got to do 0.05 divided by 52. Okay, which is 1 point, let's see here, 0.00096 dot 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 to the 52t. Okay, how much we have in 5 years? Well, in 5 years you plug in 5 for t, so we have 500 times our answer from the 1 plus our answer from the previous problem. Okay, to the power of 52 times 5, and I'm getting $641.93. So you made about $141.93 without doing any work whatsoever. Last is how long will it take your money to double. So we want to find out when will 2 equal our multiplier, which is 1.00096 dot 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 to the 52t. Again, anytime a variable is the exponent, we're taking the log of both sides, okay? And then we're going to use the power law to bring that exponent down, and we're going to divide by the log of 1.00096. So 52t, 52t here ends up equaling, in short, the log of 2 over the log of 1.00096. So log of 2 okay, let's see here. The log of 2 divided by the log, my answer, is this, and then I divide that by 52 time, I get 13.87 years. Okay, 13.87 years for your money to double. That's a long time. However, you had $500, now you have $1,000, and you did no work to earn that. And I'm going to go ahead and stop this for now, and we'll come back and do some more later.